In this video, I'll give some background information and basics concerning the conjunction between Jupiter and Saturn that will occur December 21st of 2020. I'll define conjunctions, I'll describe planet orbits in our solar system, why they lead to conjunctions. I'll show a few photos I've taken of Jupiter and Saturn in 2020, and I'll show the separation in a drawing between Jupiter and Saturn on December 21st, the main event. If you'd like some other information concerning this, I'm going to post a longer series of photographs that I've taken from September through December in a separate video. And I'll show how I've measured the angle between the objects. In another video, I'll talk about why Jupiter and Saturn conjunctions occur about every 20 years. To find these other videos, I would suggest you subscribe to my YouTube channel. View my playlist that's titled Astronomy, Images, and General Interest, and then look for the video titles Jupiter-Saturn 2020 conjunction, followed by some other information. So, a conjunction. A planetary conjunction occurs when we see a close approach on the sky of a planet with a star, another planet, the moon, or the sun. In this particular case, Jupiter-Saturn, it'll be two planets on the sky that appear to be close to each other. I need to emphasize they are not actually close to each other. Absolutely no danger of a collision. It's only our point of view. It's only our point of view. We have a view out into space that is basically two-dimensional. We see the stars and we see the moon and the planets, and those objects are all very far apart from each other. On the sky, occasionally, they may look close to each other, and that's a conjunction. That's called a conjunction. So it's a point of view situation. A photograph I found from May of 2013, a conjunction of Jupiter, Venus, and Mercury, and these objects were about 3 degrees from each other. A conjunction is a little bit arbitrary on how close the objects have to be. I'd say 3 degrees is kind of the upper limit. A conjunction, an interesting conjunction, the objects would be closer to each other than 3 degrees. The orbits of our planets in our solar system, Mercury, Venus, Earth, and Mars, the asteroids, then Jupiter, orbit of Saturn, Uranus, and Neptune, and then the minor planet Pluto further out. This drawing is not to scale. It's not to scale. There's much more separation when you get to the outer planets than is shown in this slide. What is worth using this slide for is that the planets do orbit roughly in one plane, going around the sun. Sort of if you would put objects on a tabletop and move them around, the planets would be rolling around on the tabletop, the sun at the center of their motions, and that's roughly a description of how the solar system operates for the planets. As far as the time to move around, of course, it takes the Earth 1 year to move around the sun. Jupiter, further out, the planets take a longer time to move around the sun. Jupiter, almost 12 years. Saturn, 29.5 years, roughly. So this affects how often the planets tend to line up on the sky. And we'll get to that more detailed in another video that I've referenced already. But here we are, 2020, and it's time for Jupiter to come around here and kind of overlap Saturn. And from our point of view, Jupiter and Saturn will be in the same direction in space. Another view of this from a website that I'd recommend that you go to. The reference is down here. So I put in December 21st, 2020. This gives an overhead shot of the solar system. Sun at the center. The Earth is back here. And as I look out in the sky, Jupiter and Saturn are about in the same direction. To try to highlight that, I put a line on this slide, starting at the Earth, going past Jupiter, going past Saturn, and they're going to be within 0.1 degrees of each other. A very close conjunction, as conjunctions go. Another view of our solar system using a NASA website, space.jpl.nasa.gov. And you can put in any date that you wish. You can put in where you're going to view the objects from. But again, Earth back here, and then looking out, Jupiter and Saturn are in the same direction in the sky as viewed from the Earth. Now, the planets do not orbit on a tabletop exactly. If we call the tabletop the plane of the Earth's orbit, that'll be our reference at 0 degrees, the plane of the Earth's motion around the Sun. The planets, Jupiter and Saturn, are tilted. Their orbits are tilted. 1.3 degrees for Jupiter, 2.5 degrees for Saturn. A small tilt, but it does affect how close the conjunctions are, how close the planets are at the time of conjunction. Pluto, the minor planet, its orbit is tilted at 17 degrees. It's much different than the orbits of the planets. So 17 degrees away from our reference line, our reference plane of the Earth's orbit around the Sun. Now, Jupiter and Saturn, I took some pictures starting this summer, and here's a photograph from August 11th. So this is in southwest Omaha, so there are street lights here, and it wasn't totally dark. We have Saturn and Jupiter, and then perhaps you can see these small points of light over here. This is the asterism of the teapot in Sagittarius. So these planets were east to the left of the Sagittarius constellation. Here I drew some lines on my slide to show the teapot. Again, the teapot is not a constellation. It's an asterism, a pattern of stars. It's a nice one. The constellation in this asterism is located in is Sagittarius. And then September 30th. For this photograph, I enlarged or cropped my photograph to show more details. So Saturn here and Jupiter here, and some other small stars. But I'd like you to pay attention to this line of 4 stars here. 1, 2, 3, and 4. So on September 30th, Jupiter was off to the right and a little lower than those stars. And now, mid-November, November 16th, here are these stars. 1, 2, 3, and 4. A little faint. If you go to my other video of my photographs, you'll see this a little better. But Jupiter has moved from roughly this location in September to this location in November. Meanwhile, Saturn also has moved a little bit. But Jupiter is moving faster on the sky than Saturn. Jupiter is catching up with Saturn, and when that catching up is completed, that's our conjunction. December 21st of 2020. At this time I did some measurements on my photographs, and I calculated 3.6 degrees between the two planets, and I think I have that 7.4 degrees separation between the planets on September 30th. So, angles on the sky. Here's our moon, full moon, and the full moon has an angular diameter on average of 0.5 degrees. This varies, but I won't go into that. So about 0.5 degrees for the angular width of our moon. On the conjunction of December 21st, 2020, Jupiter and Saturn will be 0.1 degrees apart, 1/5 of the angular width of our moon. That'll be the separation. And if you have a telescope, I'm told that you can see Jupiter and Saturn in the field of view without moving the telescope. They'll be together. As I calculated, I looked up in the planetarium program Stellarium. You use Stellarium to find the angular size of the two planets. Jupiter, 0.0092 degrees, Saturn, 0.0043. I put this up here. Their separation will be 0.1 degree. Their images will not overlap. They'll be well separated objects. This is the angular size of each object. The two objects are going to be 0.1 degrees apart, so they will be well separated. There's some great information about the conjunctions of Jupiter and Saturn in Wikipedia. It's under the title of Great Conjunction. Great because the two great planets of our solar system, Jupiter and Saturn, the two largest planets, are close together in the sky. They point out, and there's a table that will confirm this to you, these conjunctions occur about every 20 years for Jupiter and Saturn. And again, I'm making another video that explains why this occurs. So they'll be 0.1 degrees apart. Jupiter will be will be south of Saturn on the sky. And this is the closest these two planets have been since 1623. The 2080 conjunction will also be a close approach, about the same value of closeness. The conjunction in 2060, 20 years in between, is not quite as close, but still be worth viewing if you have an interest in astronomy. If you have an interest in astronomy or physics, I'm a retired physics and astronomy teacher, and I've made some simple websites here: physics.gpclements.com, astronomy.gpclements.com. These are totally free. They're very simple. They're not fancy websites at all. You do not give your email or your name or anything else about yourself. I do not use cookies. I do not ask for any donations. All this is free. At these websites, you'll see a list of my YouTube videos for physics and astronomy. Each video has a title, how many minutes long it is, and a little description of the video. If you enjoy these, please subscribe to my YouTube channel and watch some other of my videos. Meanwhile, keep watching the sky.